Hi, today we're going to be looking at this Kitchen Boss G320 Sous Vide cooker. So I bought this on eBay for spares or repair. I think I paid around £15 for it, and it was advertised as being faulty. So let's get it out of the box. A nice little pouch there for storage. So this is the main unit here. It's stainless steel with a control knob here and an LCD colour display. So the way this is supposed to work is you immerse this in a pan of water and it precisely controls the temperature while circulating the water, and you cook your steak or whatever in a vacuum bag and it retains all of the juices and it's more moist and whatever. So that's what it's supposed to do. And this is the little clamp that attaches it to the pan. So I'll just get this box out of the way and we'll plug it in and we'll see what it's actually doing. Right, let's undo this power lead a sec. And I think I'm going to plug it into my dim bulb tester. So I'll just go and grab that. I'm back with the dim bulb tester. So let's plug this in. And we'll switch it on and we'll see if it does anything. And not a dicky bird. It's not drawing any current because, or it's drawing very little current if any, because the bulb isn't lighting up, and it's not switching on. So totally dead. Right. So I think the first thing we'll do is check the mains fuse. Just pop the fuse out. And it's a DaVinci 13 amp. Which might be a bit big for this actually. This is like 1100 watts. So I'll have to work out. Might need a 10 amp fuse in this or something. Right, let's get the test meter and we'll test this fuse. So let's go into continuity. And the fuse is intact. So whatever the problem is, it must be internal, it's not the fuse. So I think we need to figure out how this comes apart. Let's get this out of the way for now. It actually looks in really good condition. This doesn't look like it's actually had a lot of use. So does this bottom part come off? So looks like we've got a heating element. That must be the little circulation fan. And I guess one of these might be a water level sensor, possibly, between the two of them, and one may also be a temperature probe. That's what I would be thinking. It looks like there's 4 Torx possibly up there. Let's go and grab a Torx. And we'll try removing those 4 screws, see if the top comes off or something. Right, let's grab a Torx. So this appears to be a Torx T10, but the problem I've got is, because of the position of the heater, I can't get it in at the right angle. So I'm having to use my extremely long Torx just to get in there like that. That's one undone. Right, let's see if this does anything then. And it looks like we've got a silicone gasket just around there. I'll just see if I can stop that from sticking. Well, that doesn't give a lot of access to anything. try doing this part. I should use the smaller torques for that. And that doesn't particularly give her a lot of access either. Although one thing I have noticed, I don't know if you can see there, is these screws have got a bit of rust on them. So I wonder if water's getting into this, maybe. So I'm not sure how you get into this. I know this little knob comes off. I wonder if this top part comes off somehow. I'm going to try and get a spudging tool. We'll just see if we can get this top part off. Back with a little spudging tool. Still doesn't want to come off this. I've got it off so far, but right, I'm just going to investigate this to see how this part comes off. So after a little bit spudging, this bezel does come off, and that reveals a number of screws just around the edge of the display here. So I'm going to remove those next. And I've just got another 2 screws at the top here. Right, let's see if we can get into this now then. Right, so it looks like the screen unplugs. Looks like we've got a bit of sticky stuff just holding that in place there. So let's get this screen out of the way. And that reveals another 4 screws, just with another plate down here. So let's remove that. I need a slightly bigger screwdriver. Right. Let's get these screws out of the way. Looks like we've got another gasket here. And some more electronics down there. So I think I'm going to have to disconnect this part next, if I can. There we go, that's that out of the way. Let's keep this gasket with this part. Let's put this to one side. So this looks like the main electronics in here now. So I think I'm going to have to maybe undo this cord grip, because I can't lift this part up because of the wires in the cord grip here. I don't think those wires unplug. I thought they might have been on spade connectors at first, but it doesn't look like they are. So actually it seems these are spade connectors. I've just pulled 2 of them off there. They're quite tough to get off. So there's one more remaining here. Go. Right, get that bit out of the way as well. Right, so what have we got in here then? Yeah, well that doesn't look too good, does it? We've got, looks like something exploded down in here. Looks like one of the relays actually. Let's see if we can get that bit out of the way. see if I can get this earth wire off. I know some spade connectors have got a little press in tab, but these ones haven't. They're just on really tight. I'm just trying to see if we can unplug these motors and that somehow, because that looks soldered onto the board. Let's see if we can unplug these connectors at the top here. Let's see if we can get any more access into this thing. I mean, whether or not we can repair it or not is another thing, because it looks quite badly damaged. Still haven't worked out how we get these boards out. Because when you look down there, it looks like it's all siliconed in. Unless it does unplug from that end. I can't really see at the moment. Right, I'm just going to pause and see if I can work out how these boards come out. Right, figured it out. The heater is just on two spade connectors there, and then this motor just plugs onto that connector there. So that should be the heater and that assembly separate from this now. So let's see if this board wants to come out now then. Yes. Oh. Let's just zoom down a bit on that then. It looks like that relays took a fair bit of hammering, I'd say. I'm surprised that the fuse is intact there still. Or it looks intact anyway. So it looks like we've got a little switch mode power supply on this side. A little buzzer there. And then it looks like this power relay board is controlled through here. And the power for the power supply goes in through here. I'm just wondering, because this relay has failed so catastrophically, if it's possible that some of the high voltage is getting into the low voltage stuff and maybe blew something like the microcontroller up or something like that. But I think the first job I'm going to have to do is try and separate these two boards. So I'll get the solder iron and the solder sucker out, and we'll take off these solder connections here and see if we can separate these two boards, because it's going to have to be separated in any case to even possibly change that relay, if that's the only problem. Right, and we'll get the soldering iron out. Right, I'm just going to add some fresh solder to these first. Right, I'm just going to have a quick look through the spy gas just in case there's any of these need a bit more taken off. Right, managed to get the two boards separated. So what I'm going to do is just give this a bit of a clean up on my bench, because I'm getting covered in black carbon soot off these relays. So I'm just going to put a bit of IPA on this. I'll get the cotton bud. I'm just trying to get the heavy off at the moment. Just give this a quick wipe over as well. I think I might need a bit more than that. Well, I've cleaned the bench down, washed my hands, and I thought I'd grab myself a nice cup of coffee. And I noticed one of the relay contacts fell out. So I think this is the relay that goes to the heater by the look of things, because when I trace the contacts through here, it goes to that terminal there, which is one of the ones that the heater was plugged into. I don't know what the other two relays are for yet, but that definitely looks like the main heater one. And I think what I'll do with this part, because this is all quite black and that and stuff, I might throw this in the ultrasonic cleaner just to clean that up. Save messing around with IP and stuff. So let's have a look over these boards then. I couldn't see anything obvious. I think it was just the relay by the look of things. But that doesn't explain why it wasn't powering up. I'm just trying to work out why it seems to have a few relays. Unless one switches the live and one switches the neutral, maybe. Yeah, that could be it, because it looks like that one goes across to that contact, to the heater. And then this one possibly goes across to that contact, to the other heater terminal. So it might be that they're using two relays, one to switch the live and one to switch the neutral. Sort of sharing the load between them, possibly, I don't know. I don't know what this one's for then. Possibly for the motor. But the motor's only 12 volt. It's actually got written on the back of the motor here. DC 12 volt. One thing that I might check is check that this heater isn't shorted out. So let's do that. I'll just zoom out a bit. Just grab the test meter. And we'll just go into ohms and we'll just see what reading we get between the two heater connections. And about 48 ohms, so yeah, so it's not shorted. Let's just check between one of the terminals and ground, just in case it's internally shorted. And that looks okay. So I'd say the heater's good. So the heater looks okay. I'm not sure about the motor, but I wouldn't have thought that's going to cause any of the problems. So I would have thought the motor should be alright and the heater's okay. So I'll have to have a look at these relays, see if we can order one of those. I might pull that one out. Looks like there's 4 terminals on the relay. 1, 2, 3, 4. Let's see if we can get that out then. Just going to add a bit of fresh solder first. It's caught on that one still. Yeah, I mean the traces on the board look okay. Still doesn't explain why it wasn't powering up though, because the fuse looks intact. Let's just double check that with the meter. Looks like the live comes in here. Yeah, fuse is intact. And then it goes to this terminal. And the neutral goes to that terminal. And then that should go through to the little switch mode power supply here. So I wonder if there's a fault on this possibly as well. I mean, we could try powering this up separately. I could stick some mains on there and then connect the display up and just see if we get anything on the display. I might try that. So this should be 12 volt output if that's what the motor is, and that's what the relays probably are as well. So let's just have a look at the relays, see if they're 12 volt as well, I would have thought. I can't see what voltage they run on. It says 30 volts DC, I'm not sure if that's the output. Unless it goes off that number there. I'll have to search that number and see if it tells you on the data sheet. YX202S112DMF. So perhaps the 112 is the voltage, so 12. I wonder if better quality relays may help. Let's just have a look on this little power supply board, see if I can see anything. Well, I can't see any fuse on the input. It just looks like the live and neutral goes to this inductor here. And then through the bridge rectifier here. And we've got a couple of main smoothers. And then there's a couple of 1 ohm resistors there. Looks like 1.4 ohms and 1.6 ohms. So unless they're using that for current sensing. But I can't see any protection on this power supply. I would have thought there would have been a fuse or something on this, but it doesn't appear that there is. Let's just check that we haven't got any shorts on this. I wouldn't have thought we would have, otherwise we'd have big burn marks on this as well. I'll just zoom out a fraction. I'm just going to go on to diode check first. So the bridge rectifier is okay. Let's just go across these resistors. Yeah, they're okay. Let's just check this diode here. Yeah, that's fine. That must be the output rectifier diode, so we'll just check that. Yeah, that's okay. I can't see anything wrong with this power supply, so I'm wondering why it wasn't switching on then. I'll couple some mains up to this and then we'll connect it to the display. We'll see if we get anything on the display. One moment please. So before I connect it to the display, I'll just wire it up to the mains here and we'll just check that we're getting any output out of it. That's if it doesn't explode on the bench. I've got to connect it to the dim bulb tester, so let's just switch it on. I don't seem to have anything. Let's just see if we get any output. Yeah, so we've got 12 volts there. So the little power supply is working. Right, I'll get the display coupled up next then. Right, I've got the display hooked up. Let's see what happens if we switch it on. Well, absolutely nothing. Let's just check if we're still getting voltage out of the power supply. Right. What's happening there, if you can see the meter there pulsing, it sounds like the power supply's firing up, detecting a short, and then shutting back down. So that's not looking good. I'm just wondering whether some mains voltage is fed back up one of the control wires and then into the microcontroller. Right, I'll switch this back off for now. Let's just see what resistance we get. Alright, we've got 5.6 ohms on the output of the power supply here. Let's unplug the display. And then just check that again. Oh, about 320 ohms there now. So it seems like there's a problem on this display as well. Let's just hope it's not the microcontroller. Looks like we've got some transistors there. So hopefully whatever's gone, I might have just took one of the transistors out. And we've got a voltage regulator there as well. I'll just zoom down a bit so you can get a closer view. Right, let's see if we can find out where this short is. So it looks like we've got a little voltage regulator there. I guess this is going to be ground. So we've definitely got some kind of short going on. That's the input to the voltage regulator. I think that could be the output. One of them's the input. Can't remember which way around it is on these voltage regulators. That's not looking very good. I'll take this board out. That might be the magnetic part for this rotary switch here. Let's see how the display comes off. And let's just zoom down a bit on this microcontroller. So it looks like we've got a little serial flash chip there as well. So perhaps that stores the firmware or the images that it displays on the screen. That would make more sense, because I don't think that ARM chip's got a particularly large amount of memory. So this might be used for storing things like the pictures on the menu when you scroll through it. Yeah, so it looks like that's the output pin there. I think that was the one that had the lowest resistance, if I remember right. Yeah, about 2 ohms. That looks like a 3-volt regulator. So what we could do is try some voltage injection on this. If we connect the ground up and then put 3 volts into there, and then we can monitor and see what gets hot. But I've got a feeling it's going to be the microcontroller. Let's just try some of these transistors first. Just going to diode check. I mean, it could just be one of those capacitors maybe, but I think we might be clutching at straws, but you never know. Right, I'm going to hook the bench power supply up. Right, I've tacked a couple of wires on there. I've got a ground wire here, and I'm going to be injecting voltage into the output of the voltage regulator, which goes to the rest of the circuit board. So I'll just get the thermal camera out. I'll just switch it on. And what I'm going to do is just switch this on now and we'll see if anything gets hot. Oof. I think that's the problem. That's the corner of the microcontroller there. And I'm only injecting 1 volt at 1 amp. Actually, it's only at half an amp, and it's taking the full half an amp. And you can see the hot spot on the corner of that IC there. So that is just there. So what's happened with this then is pretty much what I thought might have happened, is when the relay is shorted, it sent 240 volts up one of the low voltage connections, and it's gone into the microcontroller and fried it. So unfortunately I don't think we're going to be able to fix this one, not unless we can get a replacement microcontroller with the correct programming for this model of cooker. So that's a shame. I mean, I can try emailing the company, see if they'll help, but you know, I haven't had, I think there's only ever one company that was willing to help us, and that was Peak Electronics, who supplied us with a microcontroller for their little Peak tester. Like I say, cracking little company, supplied us with a chip for this free of charge. And people were saying like, oh, it's because you're a YouTuber. Well, I didn't tell them I was a YouTuber. I just said, can I buy a chip for this? And he said, yeah, I'll send you one free of charge. I was like, right, okay. So, cracking little company. If you ever need any test gear, I definitely recommend them. Right, I'll have a look on the internet. I'll see if we can get any spare parts for this. And if not, well, I don't think we're going to be able to get any further with this one, unfortunately. So I've been online to see if I could find a replacement board for the display for the machine. And I was surprised to find on the manufacturer's site that they actually do sell a display board, but it's actually for a different model. So what I've done is I've sent them a message to see if they sell a display for this model. So I'm just waiting for them to get back to us, so we'll take it from there. While I was waiting for Kitchen Boss to get back to us, I thought I'd remove this EEPROM here and see if it contained any data. So I put it in the EEPROM reader, connected it to the computer, but unfortunately it just seemed to ID as FFFF, and that's all the data it contained. So basically that's been fried as well. So hopefully Kitchen Boss will get back to us with some good news. Well, some good news. Kitchen Boss did actually get back to us, and they sent me a link to a replacement power supply relay board. And it was actually reasonably priced as well. It was $8.99. So I was a little bit impressed with that. So I explained to them that it was actually the display panel board that I required, and that I should be able to repair the relay board. So I sent them a picture of the display board, and then I get a reply back saying, like, unfortunately this board is out of stock, and could they replace the unit under warranty? So at that point I explained, well look, it's not under warranty. I bought it faulty to repair on my YouTube channel. And then they kind of changed the tune a little bit on that one, and what they said was, well look, we'll buy a new unit for you, disassemble it, and we'll send you the parts. So I thought, well, that was very kind of them, but whether or not that would happen to just generally anybody else, I don't know. So I just thought I'd let you know that. So when the parts arrive, we'll see if we can reassemble it, and we'll see if it all works. Well, it's been a couple of weeks and the parts have arrived, and what they've sent me is a replacement display, which is actually a slightly different revision to the original one. They sent me a new power supply and relay board. And one thing I have noticed, I'll just zoom down a bit on this so you can have a look. Is that these are different relays. The one that failed was a Yongneng relay. And I'm not sure what make these are, but they're actually different. So I wonder if they've changed these. I don't know if the board revisions are the same. Yeah, the board revision's the same. Actually slightly different. Because I noticed that one's got some identifier on here and this one hasn't. But it's still a G300B-2. The same as this one. So that's the difference between those two boards. Let's have a look at the display boards. So this is a G320-1, and on this one, this is a G320-1A. I've noticed the controls are slightly different as well. This is on-off on this side, and then we've got set and temperature or time, I think, was on the center button here. Where this one's got like an eject symbol on the button. The timer's there and the temperature settings on this side. So they might have changed the software slightly as well. I've noticed this one has got a connector here. And this one's just got a header for one. And that's a through-hole connector. This one's surface mount. And there's other things slightly different as well. It's like there's a crystal there that's not on this side, must be on the other side of the board, so they have made a little bit revisions on it as well. This one's got quite a bit more shielding on as well, I've noticed, like ground plane on the top, where this one seems to have less. Right, let's see if we can remember how it goes back together, because it's been a couple of weeks since I've took this apart. So let's see if we can remember how it goes back together, and then see if it all works. Right, let's get on with assembling it then. So to save a little bit of time, I've already attached this white plastic part back to the black part here. And the way that goes is this large window here at the front goes towards where this stainless clamp is that holds either the temperature probe or water level sensor. Next we've got the board to go in, which just slides in here. So just check we've got that round the right way. That goes in there like that. Let's see if we can figure out where these wires go now. We've got the motor one. Now it shouldn't make any difference which way the heater wires go. I'm just trying to get them so that a bit more compact. I guess I like that. Then we've got the earth wire to go on, like so. Now we've got a couple of little plugs here. And then there was some tape down the sides here. I've still got the original bits of tape, so I might as well reuse those. Just put these wires down here. Right, and there was this ring thing here. Make sure we get that round the right way. And that pushes up against a rubber seal that's around the bottom here. next this goes on. And then we've got the wires to reconnect for the mains input. So I'll just go and grab those. I think this might be one of the actual tricky parts, trying to get all these wires back on. Right, after a bit of struggling, I've gotten the wires back on. What I found it easier to do was to put this strain relief back on first and put the gasket on. So I did that first, slid this bit on, and then put the wires on. And also you've got to make sure that this part here is lined up with the white part underneath. And sort of just clicks in place when it's in the right position. Like so. And the other thing I made sure was that the Kitchen Boss logo is opposite the cable there, just so it looks a bit more back to the way it was. Right, so the next thing is this part here. So you want that bit sloping away from the power cable. So there's a little connector I've got to plug into the main board here. And that just goes on top. Try and get one of the screws in the right position first. You better pop the screws out, I think, first, or put the back one in maybe. It's hanging down. There we go. Just make sure those are tightened up properly. Try a different screwdriver, it seems to be slipping out a little bit. Right, just the display to go on now then. And they sent me some new screws and a new bezel as well, so I might as well use those. I think I've lost one of the screws on the floor, so let's use one of these ones. Use one of the original. Right, so I think what I'll do now, we'll just plug it in, see if it lights up. I'll go and grab the dim bulb tester. It's not going to work because it won't switch on unless it's immersed in water. I'll probably throw up some kind of error or something. So I'll just grab the dim bulb tester again. Let's see if it does anything now. Hey! Right, I shall go put the bezel on, we'll grab a pan of water and then we'll see if it all works. Right, back in a moment. Back with a pan of water. Now one thing I am going to do as well, this had a 13 amp fuse in and I think that's too much. So a 5 is just going to be on the limit. So ideally I'd want a 7, but I've only got a 10, so that'll have to do. It's got to be better than the 13 that they had in originally. Right, let's plug this in. Let's see what the temperature is. Get the thermal camera on. Let's see what the temperature of the water currently is. And it's about 17 degrees. So let's switch this on, which I think is the center button here. Well, it's circulating, the fans came on. Right, so I think we'll just leave it like that for a bit. It looks like it's heating up, its temperature's going up there. And it looks like the temperature on the thermal camera is going up as well. Excellent. Right, we'll leave this for a bit, see if it gets up the temperature, and then if it is, we'll call it a fix. Right, back shortly. Right, so it's nearly up the temperature. You can see the You see the swirling around of the heat there in the pan. And now it looks like it's beginning its cooking phase. Excellent. So I think a big thumbs up to Kitchen Boss for being so helpful with this and supplying parts and even supporting their customers, because they do sell parts on their site as well. So another company that's actually helpful. So well done, excellent. Right then, if you enjoyed this video, give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.